Welcome to lesson number 4. We're going to be looking at calculating the measure of an angle in right triangles. So in lesson 2 you learned how to measure an angle using a trig ratio, and so we're just going to review by doing a couple of these. So determine to the nearest degree the acute angle for which sine of x is equal to 0.45, and so if I'm looking for the angle, I put I put the ratio in 0.45. I get a value of 27 degrees if I measure to the nearest angle and round. 27 degrees. For cosine of y degrees, it's equal to 0.1624. So cosine 0.1624, and I get a value of 81 degrees. 81 degrees. Now, in order to use the trig ratios to determine the measure of an angle in a right triangle, what you need to know is the lengths of at least two sides of your triangle. And the reason you'll need to know that is so you can determine what the trig ratio is that you need to use. So if I complete the work here, relative to the angle A, so here's my angle, 16 is the length of the adjacent side, and 34 is the length of the hypotenuse. So I know it's the hypotenuse because it is opposite of my 90-degree angle, and it also appears to be the longest side. So the trig ratio for which the adjacent and the hypotenuse is the cosine ratio. So if you don't remember off the top of your head, then remember we can just go SOHCAHTOA, do our mnemonic, and then look at which one includes adjacent and hypotenuse, and that's cosine. And so my angle then is going to be equal to cosine, angle A is equal to 16 over 34. So to the nearest degree, 16 divided by 24 is equal to 42 degrees. Now we'll do a couple of these. In each case, calculate the measure of the indicated angle to the nearest degree. And this first one, in relation to my angle, I have my opposite side as well as my hypotenuse. And if we look at which one includes opposite hypotenuse, that's sine. So sine 80 degrees is equal to 4 over 6. And in order to find the angle, I would use my inverse sine, 4 over 6, and my angle is equal to 42 degrees. Next we'll do this one here. I have 3 measurements, and so I can choose which side lengths I want to use. So I have my angle C, and if I'm looking at this side, this would be opposite of my angle, this would be adjacent, and this would be my hypotenuse. Because we use hypotenuse into the previous examples, I'm going to use my tan ratio, which includes opposite divided by adjacent. So I would set this up as tan C degrees is equal to opposite over adjacent, or 21 over 20. And in order to solve for C, I'm going to use my inverse tan is equal to 21 over 20. And my angle I get, so inverse tan 21 divided by 20 is equal to 46 degrees. Next, we're going to be looking at angles of elevations and angles of depression. So in this example, I have my helicopter and I have a boat. This line represents what they can see, and then I have an angle given here. So the angle of elevation is measured upwards from the horizontal. So angles of elevation as well as angles of depression are always measured relative to a horizontal line. So a line that goes along the x-axis, or that is the horizon. So going from across. This sketch shows my angle of elevation. So the angle of elevation of the helicopter from the boat, again, is the downward angle measured relative from my horizontal. So here's my horizon line, and this would be my angle of elevation. It would be above it. The angle of depression is measured downwards from the horizontal. And so elevation is elevating, going up. Depression is going down. So the angle of depression of the boat from the helicopter is again measured from my horizontal line going downwards. And the angles in elevation and depression are determined from the horizon, not the vertical. So this is a vertical here, and this is the horizon going across. And so that's how our angles are measured. So we'll look at a couple examples to see the difference there between angle of elevation and depression. So a tree 5.1 meters tall casts a shadow 7.5 meters long. Calculate the angle of elevation of the sun to the nearest 10th of degree. So if this is my shadow, then my sun is going to be, let's say it's like that. There's my sun. So we want to calculate the angle of elevation of the sun to the nearest 10th of a degree. And so here's call that my line of sight. But my tree is 5.1 meters and it casts a shadow that is 7.5 meters long. And so we want the angle of elevation of the sun. Now, if we're thinking about the angle of elevation of the sun, even though we're not going to be measuring anything in relation to the sun directly, we know that if it's an angle of elevation measured from a horizontal, then my ground is my horizontal. So the shadow is on the ground. This is also the horizon line that we're looking at. And so the angle of elevation is measured upwards from my horizon line. So going in this direction from my horizon line, and that's the angle that we want to find. And so here I have an adjacent side as well as an opposite side in relation to this angle. So I would use my tan ratio. And I'm going to call that theta. Tan theta is equal to opposite over adjacent. And my opposite side is 5.1 and my adjacent side is 7.5. And we're looking for my tan of my angle. And so this angle would then equal the inverse tan of 5.1 divided by 7.5. So inverse tan, 5.1 divided by 7.5. And we get an angle equal to 34 degrees. Next, we have the opposite. We have a boat that is 130 meters from the base of a cliff, and the cliff is 80 meters high. So the first thing they want us to do is draw this scenario and mark the angle of depression of the boat from the top of the cliff. So here's top of a cliff, and a boat is found. There's my boat, and that is found 130 meters away. And we want to know, there's my line of sight from each of them. And what we want to know is the angle of depression of the boat from the top of the cliff. Now, my horizon line is going to be across here. And remember, the angle of depression is always measured downwards. So here is my angle of depression here. All right, there's my angle of depression, and my cliff is 80 meters high. So the next thing we want to do is determine to the nearest degree the angle of depression. So we want to know what that value actually is. Now, this is where it can become a little bit tricky, is just visualizing what's going on here. Now, or just finding where my triangle is, right? So we could look at this triangle here, or we could also look at this triangle here that has the legs of the distance and the height of the cliff. And so if we're using this triangle, then we could also reason that angles will combine to equal 90 degrees here. So if this, and that's what we're looking at here, is this 90 minus, but we could also, and if we do find out what this angle, and I'll call this angle B, if we find out what this angle is, it's not going to necessarily equal this side. But we could also solve for this angle, and this angle, as well as my angle theta, my angle depression, are going to be equal. So let's find out what, let's solve for this angle here. And what I have is, again, my adjacent side and my opposite side. So tan 80 degrees is equal to adjacent or opposite divided by my adjacent side. And so this is going to be tan negative 1 is equal to 80 over 130. So A is equal to 32 degrees. 32 degrees. So the last example, I'm not going to do this one on the video, but all we need to do for this example is consider this triangle, and we have all the side lengths. So KL is 20, LM is 20 centimeters, and KM is 30 centimeters. And then it says, well, why can't we use SOHCAHTOA in this triangle in triangle KLM to determine the measure of angle KLM? So in looking for this measure of this angle, why can't we use SOHCAHTOA? Well, the reason is triangle KLM is not a 90-degree triangle. And actually I'll do this example here, but in order to find out this measure, what we'll have to do is split it in half, like so. Now we have two 90-degree angles, and I can solve for double this triangle, in which case now from each length is 15 centimeters. So if I only solve for half of the triangle, then what I have is I have the hypotenuse, and I have and if I'm looking for half of this angle, then I have my opposite side. So I could use sine, and I'll call that 80 degrees is equal to opposite over hypotenuse, which is equal to the opposite side, which is 15 over my hypotenuse of 20. And remember, this is for half of the angle. And then I would type in my calculator, inverse sine of 15 over 20. So my inverse sine, 15 divided by 20, is equal to 48.59. But remember, that's for half the triangle, so I have to multiply that by 2. And the actual measure of that angle is going to be 97 degrees. And that's for angle KLM.